Chapter 7. The Process of Sampling. Frequency Domain. I introduced you to the fact that the sampling process in the time domain is where we take a signal x of t, which is a continuous signal, we multiply it by p of t, which is an infinite pulse train, to produce xp of t, which is our sampled signal, and this is what becomes our digital signal, such as what could be used in a computer. You know that all time domain signals will have a frequency domain representation. So x of t will have a frequency domain representation x to j omega. If we consider that we have a signal x of t, it will have a frequency domain representation. For the sake of illustration, we're going to say that this time domain signal, which is arbitrary and not any one particular signal we care about, but is trying to represent in an illustrative fashion all possible time signals, has a frequency domain representation as drawn here. This particular time signal will not have this exact representation, but this is just trying to illustrate what a possible frequency domain representation might look like in a form that's easy to draw. This has certain characteristics which are important to our analysis. We know x of t is a real signal. All values are real, not complex, not imaginary. Therefore, its spectrum will be symmetric around 0. It is important for this analysis that the spectrum, when we are beyond a value omega m, and when we are before a value negative omega m, have amplitude 0. Therefore, we can say that it has non-zero values only for frequency values between negative omega m and positive omega m. We call this a band-limited signal. There's a limited number of frequencies in which we have non-zero values. Okay, p of t will have a frequency domain representation, p of j omega. We know that p of t is our infinite pulse train. That infinite pulse train, in Chapter 4, Table 4.2, Transform Pair 7, we introduced that the transform of it was also an infinite pulse train, but now with area 2 pi over t, and with pulses spaced 2 pi over t apart. So if we have our time signal with area 1 and spacing capital T, our frequency signal is now plotted versus omega and will have area 2 pi over t. So our time signal will look like this, and our frequency representation will look like this. Very similar. We use omega s as 2 pi over t for reasons we'll see later, but you should have a hint for why based on Chapter 3. Our xp of t will have an xp of j omega. We saw in Learning Outcome 4.3, Properties of Fourier Transforms, that the product of two signals in time will have a transform 1 over 2 pi, the convolution of their two transforms. And we use that here to say that the product of x of t and p of t in the transform domain will be 1 over 2 pi x of j omega convolved with p of j omega. So now we have our x of j omega and our p of j omega. We now want to figure out what is xp of j omega. We know that xp of j omega is the convolution of this triangle and these impulses. In Chapter 2, Text Problem 2.23, which has been assigned to you, was a similar problem where x of t was an infinite pulse train, h of t was a triangle, and you were tasked to find y of t, which was a convolution of the pulse train and the triangles, when our pulse train had spacings 4, 2, 3 halves, and 1. I hope you've completed this. Please find your work for this. You will need to use that here. The process of sampling, as viewed from the frequency domain, is the same problem. But now we have a scale factor of 1 over 2 pi. Our variable is omega instead of t. And instead of being spaced capital T apart, our impulses are spaced omega s apart. And instead of our impulses having an area of 1, they have an area of 2 pi over t. And we say that our triangle goes from minus omega m to positive omega m. But overall, this is the same problem. Now I want to ask you some more questions. What would be our sampled spectrum if our impulse train had an omega s value of 1 and our time signal had a spectrum with omega m of 4? Please do these calculations on paper and bring them with you to your next class. Likewise, what is xp of j omega if omega s is 1 and omega m is 2? If omega m is 3 halves, and if omega m is 1. Working out these 4 problems and bringing the answers with you to class is your assignment. If you have questions, ask me, ask your classmates, and go back and review other videos, and pay a lot of attention to your results from problem 2.23. See you in class.